Okay, so this is actually day 2 of the ellipsis lesson. So today what we're going to be doing is writing the equation of an ellipse. Now, just to review, because I know we did this before spring break, remember that when your center of your ellipsis is at the origin or at the order pair 0, 0, so when you're given a center at the origin, our equations are going to be either x squared over a squared plus y squared over b squared equals 1. They're always set equal to 1. Now, this would tell me that because my a squared is under the x squared, this tells me that my major axis is horizontal, or the x-axis is going to be the major axis. Now, when you have the a squared, and if it's under the y squared, this tells me that my major axis is going to be vertical. This is the standard form of the equation when the center is at the origin. Now, remember when we graph these, so for example, if your ellipsis looked like this, let's say it's here, and that's not a very good oval here. Let me see if I can fix this a little bit better. So this would be, let's say the x-axis is the major axis. These points right here would be the vertices. The points right here would be the co-vertices. This would have a center at the origin. And then also remember, you also have a focus point that is also found along the major axis. So these are all going to be clues for us when we're coming up with our equations. So always remember the focus point is along the major axis. Now, if our graph were more vertical, let's say the ellipsis went up and down along the y-axis and it was vertical, this time our vertices would be located along here along the y-axis, and the co-vertices are located at the ends of the minor axis. Again, a center at the origin. And again, our focus points would be located somewhere on the major axis. Remember, these foci, or these focus points, are equidistant from any point on our ellipsis. All right, so that's what we covered before the break. So we were given an equation, we were asked to find the vertices, co-vertices, focus points, and then create a graph for it. Now what's going to be given to you is either a vertice, the center, the major axis length, the minor axis length, a focus point. From our given information, we're going to come up with the equations. Okay, we're also going to be given problems where the center is not located at the origin. And those are when we're going to pull in a center point of H and K. So just to modify for the horizontal, again, the a squared is still under the x. So this would be x minus h squared. Still has the a squared underneath the x squared term. And then y minus k squared. And the b squared's underneath the y. That's still a horizontal. And then for the vertical, what changes is the location of the a squared. So now the b squared's under the x, and the a squared is under the y. The h is always with x, the k is always with y. So the only thing that switched were the location of the a squared and the b squared. So when it's horizontal, it's under the x. When it's vertical, it's under the y. So that's just a quick review of what we've done. Now we're going to come up with writing these equations. Pretty good so far? Let's move on. Anybody still need that? All right. So here's my first example. Again, it's giving me the center point, and it's telling me that it's located at the origin. Now, when we did this lesson for the parabolas, I told you to give yourself like a rough sketch of what this looks like. So I could go ahead and quick draw or graph the information that's given to me. So far I'm given a center point of 0, 0. I'm also given the focus points. My focus points, I could pull these apart and say it's the ordered pair 0, 3 and 0, -3. Notice the plus minus. So I'll go ahead and graph both of those. And I'll go ahead and put my focus points in. Remember, the focus points are always along the major axis. So this is telling me, because I just graphed them, that my major axis is the y-axis, so my graph is going to be the vertical. So my a squared is going to be under the y squared. So the standard form that I need to come up with is this: x squared, and this one gets the b squared, because again my graph is vertical. And now what I need to find the value of is the b squared and the a squared. And here's how we're going to do that. Now, whenever you're given a major axis length, remember that is the length of the entire axis. So we know that on either side of that center point is half of this. So the major axis is always your a value. So I'm going to do 8 divided by 2 because there are 4 on either side. And this is my a value. The major axis is always a. The minor axis is always b. Now, I don't need a for my formula. I need a squared, so I can square the 4. So far I found part of my formula. I found a squared. So far, I've got this part. This stays here. The plus sign stays. X squared changes, or stays. And now I need to find b squared. Now, I can put in my vertices. If I already know that the major axis needs to be a length of 8, then I could count and make sure that I have 8 separations. Right now I have 1, 2, 3, 4, 5, 6. So I could draw in my vertices if I wanted to. So I can see here that my vertices are going to be here and here. Because if you count, there's actually 1, 2, 3, 4, 5, 6, 7, 8. It's 8 in length. Now I need to find my C value, or my B value, sorry. Now, from the focus point, or the distance from the center to this focus, you can see that it's 3. So if they give you a focus point, this is your C value. Good? Okay, so I'm going to do C squared is equal to A squared minus B squared. So now C squared is actually 3 squared, which is 9. So I'm going to do 9 is equal to 16 minus B squared. I'm solving for B squared, so I'm going to subtract 16. Get -7 equals negative B squared. Divide by -1, and B squared equals +7. I don't need to square root it because I want B squared. So now I could just take what B squared equals and put it right here. And I'm done. And I have it in standard form. So the C is going to come from the focus. It's going to be, it's an equidistant from any point, so it's equidistant from that center. So you could use the center point. Again, we still have our center at the origin. So we really don't need to draw a picture. I can already see that my vertice is going to be horizontal because that's where the number is. Notice in the order pair x, y, so in my vertice, it's the order pair 3, 0 and -3, 0. So I could actually do this without drawing a picture, but let's go ahead and sketch one. So if I were to graph the two vertices, well, I'll graph the center. Then I have a vertice at 3, 1, 2, 3, and 0. And then I have one at 1, 2, 3, -3, and 0. These are going to be my vertices. And then I also have a focus point. And the focus point is going to be at +2 and -2. And again, remember your focus point is always on your major axis. So again, this is a clue for me. Soon as I see that my vertices and my focus points are the order pair something, 0, I already can see that my axis is going to be, my major axis is x. And that's where my bigger number needs to be under. So again, clues of how to eliminate some choices here. All right, so again, major axis is x. So this is the standard form that I'm looking for. Is x squared over a squared, y squared over b squared equals 1. Again, I can get my a value from either a vertice or a major axis length. So on the other one, it gave me the major axis length, and I divided that by 2, and that was my a. This time I actually have the vertice, so my a value is 3. A squared is 9. Now again, C will come from the focus when it's at 0, 0. So my C value is 2. So C squared is 4. So again, I don't need C squared in my standard form, but I do need B squared. So I'm going to use the C squared equals A squared minus B squared to find the value of B squared, because I have A and C. So C squared is 4, A squared is 9. Solve this equation for B squared, subtract the 9, divide by -1. So my B squared is equal to 5. So now I can just take those two values that I found, the A squared equals 9 and the B squared equals 5. Plug them in. X squared, the A squared goes here, Y squared, and that value is 5, and it always equals 1. And that is the standard form for that given information. So when the center is at the origin and you're given a focus and a vertex, all you need to do is plug it into the C squared equals A squared minus B squared, find the B squared, and then plug it back in. The next one's a little bit more work because they're giving me a vertice and a point that is on the ellipsis. So let me go ahead and try that one. So here, I could graph it. So let's see, let's graph. So my vertices, you can see that my major axis is going to be Y. So when I go to graph these vertices, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, you're going to see that the major axis is the Y-axis, or it's vertical. And again, the major axis or your vertices tells you your A value. So A is 5. So A squared is 25. Now, it's only giving me a point that's on my ellipsis. 1, 2, 3, 4. So my point is here. So I know my ellipsis is going something like this. Now, remember, in your order pair, the first number is x, second number is y. Now, from my vertices, I know the standard form that I'm working with is the x squared over b squared, because again, remember, your major axis is vertical, so I need the a squared under the y squared. And now what I'm going to do is plug in my given. Okay, I can't do the c squared equals a squared minus b squared here because I don't have a c value. All I have is an x and a y. So what I'm going to do is I'm going to take this 4, I'm going to square it and put it here. I'm going to take this 2, which is my y, square it and put it here. I have my a value, so I can square it and put it here. And now my only unknown is the b squared. So let's go ahead and put in what we know. So 4 squared and then 2 squared. I don't know b squared, and I know a squared is 25, and it equals 1. So I'm going to simplify. So I'm going to do the exponents. So my next step is to isolate b squared. So I need to move everything away from it. So what I'm going to do is I'm going to move this 4 over 25 to the other side, because I'm trying to get b squared to be all by itself. I'm going to actually change this whole number 1, and I'm going to make this 25 over 25. So I can subtract. So I get 21 over 25 equals 16 over b squared. I now need to find the value of b squared. I'm just going to solve this as a proportion. I could multiply both sides by b squared and then both by 25, but it's easier if I just treat it as a proportion. So multiply b squared times 21 and 16 times 25. So then I'm left with 21 b squared is equal to 16 times 25, which is 400. I'm going to divide by 21, and I get b squared is equal to 400 over 21. Again, remember, I'm trying to find b squared. I don't need b because I'm trying to get the information to plug it into this. So I'm not going to square root it. So now I'm going to plug in. I have the a squared, and I now have a value of b squared. So let's go ahead and replace what we know. So again, x squared, and the b squared is 400 over 21 plus y squared, and then remember your a squared was 25, and it equals 1. Now, I can't have a decimal in a fraction, that's why I didn't divide it, and I can't have a fraction in a fraction. So I actually need to fix that. Remember, this fraction bar means division. So really what we're doing here is x squared divided by 400 over 21. Do a keep flip change. So this will actually simplify to 21x squared over 400. So that will be my final answer. So basically just take this 21, put it up there. Over y squared, 25 equals 1. And that's your standard form. So you can't leave a fraction in a fraction. Now we're going to do a couple of examples where the center is not at the origin. So all of these had their center at the origin. Notice there were no H and K's here. Now we're going to have the H and the K involved. So for this one, we're going to try to figure out which is our major axis and which one is our minor axis. So if I want to go ahead and graph this. So again, the minor axis, remember when I divide this by 2, this gives me my B value. So when it's a minor axis, that gives you your B. So when I square 1, my B squared equals 1 also, because 1 squared is 1. So let me go ahead and get a little sketch going here. So I could graph the 2 vertices. Again, remember the vertices are located along at the ends of your major axis. So if I were to graph 1, 2, 3, 1, 2, 3, so the order pair 3, 3. And then I'm going to graph positive 3, negative 3. So you can already see that this is the ends of the major axis. So my major axis is going to be vertical. So the equation I'm going to be looking to fill in is x minus h squared over b squared y minus k squared over a squared equals 1. So because my graph is vertical, my larger number is going to be under the y. Okay, so the next thing I should find is my center point. So the center is going to be the midpoint of those 2 vertices. So if you want, you could do the midpoint formula, or because it's just a vertical line, you could just find the middle. So you can see that the middle is going to be right here, because there's 3 this way and 3 this way. So the center point is the order pair 3, 0. This is the center of my ellipse. So this is also my HK. Now, this center point will also give us our focus. So, my C value. So my C value is going to be 3. My A value, My A value is 3, because the distance from the center to the vertice is 3. So my A value is 3, and A squared is going to be 9. So I don't need to find the C value here, because all I need is A squared and B squared, and I found the H and the K. So x minus h, which is 3, squared, over the b squared, which is 1, y minus 0, which is the k, over 9 equals 1. Now, whenever your center point has your h or your k is a 0, remember that you could just simplify that and make it y squared. Or if it were x minus 0, you could just make it x squared. So that is your standard form when your center is not located at the origin, it's at the order pair 3, 0. And again, that center point is going to be the midpoint between, or the midway point between the 2 vertices. Let's try another one. All right, so again, they're giving me a major axis length. So whenever they give you the axis length, divide it by 2. When it's major, This answer that you get after you divide by 2 is the a value. So a squared is going to be 4 squared, which is 16. We can see that my major axis, if I look over at my focus point, which is always located on the major axis, I can already see that I have a number in the x spot. So I can see that my major axis is the x-axis, or it's going to be horizontal. So again, my equation is going to be x minus h squared. Because it's horizontal, the a squared is going under the x. Y minus k. It gets the b squared. And now I need to find the b squared. I found a squared. Again, I'm going to use my focus point and my center point. So let me go ahead and draw a picture here so I can find my center. Center is going to be the midpoint of these two guys. It's the midpoint of the focus. It's the midpoint of the vertices. So if I were to graph those two focus points, 0, 0, and 4, 0, 1, 2, 3, 4, you can see that the center is located halfway here, right in the middle. So the center is the order pair 2, 0. That's also going to give us our C value. So our C value is 2. So C squared is 4. So in order to find B squared, I'm using this. C squared equals A squared minus B squared. So 4 equals 16 minus B squared. Subtract the 16. Negative 12 equals negative B squared. Divide by negative 1. So B squared equals positive 12. So now that I have A squared and B squared, and I have my HK, which is my center, I can plug them in. All right, so let's plug it in. So again, let's see. I have x minus 2 squared, y minus 0 squared, and then 16 and 12. And again, I can simplify that y minus 0 and just make it y squared, and you're done. One more example. Same scenario, a focus and a major axis length. But this time, we're going to see that in the focus point, the number's in the y spot. So my major axis is going to be vertical. Okay, so again, major axis divided by 2. This gives me my A value. So in this one, A squared is 64. So again, let me draw a quick sketch here of my focus. This can confirm that I am finding the right axis or where to put the A squared. So again, I'm graphing the order pair 0, 0 and 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I can see that the two red points are my focus points. Again, the center is going to be the midpoint. So right in the middle here. So 0, 4 is your center. So you can already see that that A value, that A squared, needs to go under the Y because we just graphed them vertically. So again, my formula I'm using, x minus h, y minus k. And again, it's vertical, so the A squared is going here, B squared here. and it equals 1. So far I have everything except for the b squared. So again, I'm going to do c squared equals a squared minus b squared. And again, I'm going to find the distance or use this center point. So my c value is 4 and c squared is 16. So let's plug in. 16 equals 64 minus b squared. Subtract the 64. Negative 48. Divide by negative 1. So b squared equals 48. So now let's put it all together. So again, remember the center is HK. And we had the A from up here. So we're using this, this, and this. So my final answer here is x minus 0 squared over 48, y minus 4 squared over 64. And again, simplify that x minus 0. Just make it an x squared. And this all stays the same. Now, if you were asked to graph this, remember this is going to give you how to get to your co-vertices. So the A is always for the vertices and the B is always for the co-vertices. So if it asks you to come up with the graph, you could do that. You could add in, the rest of your points. Right now, from red to red, the 2 points here, that's only a distance of 8. So what we could do is, if we wanted to get the vertices in here, again, you take the center, which is 0, 4, and to get the coordinates for the vertices, we're going to add the A value. So add 8, and then subtract 8. So my vertices would actually be 0, 12, and 0, negative 4. So we could actually graph some vertices. So I would have to go up 4 more, 9, 10, 11, 12. So I'd have a vertice up here, and then go down 1, 2, 3, 4, and another vertice here. And then to find the co-vertices, I would be adding the square root of 48. So it'd be 48, 4, and negative square root 48, 4. Just think of it like this, that the square root of 48 is in between the two perfect squares, 6 and 7. It's closer to 7. So I would graph this up just a little bit, maybe like 6.9, 4, and then positive 6.9, 4. So if it asks you to come up with a graph, we could, 1, 2, let's see, do black. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then we could say our co-vertices are here and over here. And then your ellipsis would look something like this. So just remember the co-vertices are for the B or the minor axis, vertices and major axis, that is from the Y, the A. And then C comes from the distance from the center to the focus. So you may get a question. So your test is, majority is multiple choice. You may have a question like this where you're going to have to do everything by hand. I'll give you something. You may have to transform it. You may have to complete the square. I may ask you to label vertices, co-vertices, focus points. It may be a parabola, and I may ask you to find the focus and the directrix. So we're considering giving you one question where you may have to do everything by hand also. But that would be on a separate day. So your homework tonight is 15 through 23 all. In the file where you're going to get the assignment from, I put a screenshot of the even answers so you have access to check those. The first four, I believe, all have a center at the origin. Then I think starting on like the fifth problem, it tells you that the center is somewhere else. So just know that when you're doing it, the center is at the origin, and then from then on, it tells you where the center is located. And it's going to ask you to write equations for these. Again, if it helps you to draw a rough sketch so you can sort of see your given information and see where your major axis is located, you can always do that. So tomorrow we will move on to hyperbolas, which will be lesson 3. Any questions? All right.